Hi, I'm Howard Tiersky, CEO of Moving Interactive, with another episode in our Digital Innovation Series. Today we're going to talk about the power of effective prototyping for the creation or evolution of digital products. So what is prototyping and why do we do it? A prototype is a model of something you intend to later build on a broader scale. Da Vinci created working scaled-down replicas of his inventions before building them. Michelangelo often created small models of his sculptures out of clay before starting to chisel giant slabs of marble. Boeing creates complete virtual reality simulations of their new aircraft before firing the first rivet. So the idea of prototyping has a pretty good pedigree. And it makes sense, right? Because if you're going to make a mistake or change your mind, you'll want to do it in a medium where the cost is low to rework and improve. Now, fortunately, in the digital world, making changes to completed production websites and mobile applications is far, far easier than having to re-chisel a marble sculpture or tear apart an aircraft. So, is prototyping really relevant? Perhaps we should put all our energy into the real thing rather than creating models in advance. Well, let's consider that for a moment. There's certainly a strong argument for ongoing iteration of your digital product based on the insights and feedback you get from the real-world application once it's in production. Prototypes, by their nature, do not have the full complexity and scale of real solutions, and as such, there is a certain margin of error of what you can learn through prototyping versus the real application. But we still believe strongly in prototyping digital products, not as a means to be sure your product vision is perfect and will never change once launched. That's unrealistic. But as a way to work out as many of the issues as possible before launch. And even post-launch, it can be a great tool to keep your prototypes alive so you can continue to prototype subsequent potential iterations of the product before you implement them. In today's video, we'll talk about 3 dimensions to think about when planning your prototype. One is scope. How much of the breadth of your product should actually be prototyped? Another is the level of fidelity of your prototype. How to determine which level is appropriate for what you're doing. For example, some prototypes are simple paper representations of a planned design. Others are fully programmed simulations. We recently created a prototype for a mobile app that actually works and functions on a phone very much like the real application will. And there are many gradients between. The more realistic a prototype, the higher its level of fidelity. However, the more realistic prototype is more effort to create, more effort to change, and to maintain. So there are trade-offs. And we'll get into that in a bit. But let's start with the first dimension of prototyping, which will then actually help drive the decisions about the other 2, scope and fidelity. The first dimension is defining the objective of your prototype, or objectives. There are 5 primary reasons to create prototypes. Each of these objectives provides value in and of itself, and it may well be logical to create a prototype for just a single one of these reasons. However, very often prototypes can help achieve multiple objectives. So it's good to consider, before planning your prototype, where there is additional value that the prototype could provide, perhaps beyond its primary reason for creation. And if you wish to gain those additional benefits, there may be certain things you want to do in planning that prototype to make sure that it works well for multiple purposes. So let's look at the 5 reasons to create prototypes. The first possible objective is that a prototype can serve as a technical proof of concept. For example, you might need to pull data from several different back-end systems and combine it together in a mobile app. And you want to be certain that this data can in fact be integrated and that it can be done with acceptable performance and accuracy. This is the sort of thing that is very helpful to determine early in a project, because if you have a major technical roadblock to creating the user experience that you would like, you're far better off knowing that before you are in the late stages of development. You don't want to have completely built the front end, start connecting the pipes together, and then discover that it takes 3 minutes to render the screen, or that the system simply can't deliver the data that you're expecting. A technical POC allows you to prove out things like integration, device performance, software compatibility, or other technical factors early on. If a prototype exists strictly for the purpose of a technical proof of concept, very often it may have a very limited user interface. Sometimes it's sufficient to have, for example, a very plain form that allows, an account number to be entered, and then a dialog box might appear that tells you the account balance, or whatever the data is that you're trying to pull. The magic of a prototype like that is in what happens behind what's visible to the user. In fact, in some scenarios, it's helpful for a technical proof of concept to actually have a user interface that looks completely different than the real application will, and instead illustrates or traces the series of back-end interactions that are occurring even though, of course, in a live application, you'd never show that to a user. For example, if data has to be retrieved from 7 different systems and added together, the final production user experience might be to just show the user the result. But the technical POC might show each of the pieces of source data, perhaps how many milliseconds it took to pull each from its source system, and then the total. This allows a technical team to understand what's happening behind the scenes and isolate problems if there are any. Now, this first purpose of prototyping is often set apart from the other 4 we're going to talk about, and probably has the least synergy with the other 4, which all together involve representing at some level of detail what the actual end user experience is intended to be like. For this reason, often technical proof of concepts are standalone, and it may be that for a given project, a technical POC is done as well as another prototype which serves one or more of the next 4 objectives that we're going to talk about now. The second benefit of prototyping is collaborative visualization. Digital products are almost always a collaboration by a team of creative, technical, and business people who work together to identify ideas for features or other aspects of the experience, to prioritize them, and collaborate on the final interaction design and business logic. Prototypes take ideas and make them concrete, which can help to ensure that everyone on the team is picturing the same thing and to identify when they may not be. And as changes are made through the collaborative process, the entire group can then see how those requested changes are interpreted in terms of an updated screen layout and ideally interactive behavior in the prototype. This is especially valuable because different people on your team probably process information differently. And some people need a very concrete representation of something to really get it. For example, say you ask the business owner of a mobile banking application to sign off on a 100-page Word document of detailed requirements. It may be that in those detailed requirements, you describe every nuance of how the application will function. However, you still run the risk that that business owner may not be able to fully follow and picture what those requirements are describing. There's significant risk that that business owner may say, "It all looks good to me," and then you build the application, only to discover during the review of the finished application that they now finally see problems which were present in the original requirements, but they just didn't comprehend at that stage. So then you find yourself needing to make changes, perhaps major changes, at much greater cost and time impact than had they been recognized sooner. You can blame that individual business stakeholder for failing to read the requirements document carefully enough. However, that blame isn't very productive. Better to reduce the risk by making it easier to visualize what the results will be like. The third objective that you can accomplish with a prototype is pitching or selling your product. Here's some common scenarios. Funding. Your CEO, board of directors, or prospective outside investors need to understand the feel and function of the product before they agree to fund it or continue funding it. If the application hasn't been built yet, a prototype can help give them a sense of what it will be. Second, business development. You may be pitching several potential advertisers or customers or partners that you want to get enthusiastic about the product that you're still in the process of creating. Third, promotion. You may be trying to drum up media attention, or you may need to create marketing materials in advance of the product actually being ready. A prototype could potentially be used for that. And I'll add in here training as well. You may need to create training videos or other materials, or even start training some advanced users before the application is ready. A robust prototype can sometimes be used for these purposes. The fourth potential purpose for a prototype is developer communication. While a prototype is not a complete replacement for other forms of requirements documentation, you can reduce developer confusion, errors, or the need for heavy developer interpretation by giving the dev team a prototype that shows how you intend the final application to look and work. Some prototyping tools also allow you to cross-reference between a live prototype and documentation, allowing a developer to, for example, click on a field on a prototype page to drill into the validation rules that are needed for that particular field. It's a common problem that development teams, not ours of course, but some, don't always attend carefully to written specifications, or they might overlook some details. A prototype can help bring the complete idea to life in a way that helps keep the development team on track, as well as give them a cross-reference for the detailed nuances. The last objective that a prototype can help fulfill is user testing. Here at Moving Interactive, we're big believers in a simple concept we call DIA, the data, insight artifact cycle. We'll probably do another video to talk about this in more depth, but here's the basic idea. If you've watched our other videos, you've no doubt heard us talk about our philosophy that business results are almost always the outcome of driving human behavior. And so it's our goal to create experiences which influence behavior in the direction that aligns with both the user's goals and our business interests. In order to conceive and then optimize a digital product towards this end, we have to combine hard research, which gives us facts and helps us understand the customer's perspective, with creativity, which generates new ideas on how to support and influence that customer. So let's look at a diagram. We generally start a project by collecting data. For example, gathering information about the customer's current level of satisfaction with our client's current digital product, and also with competitive products. We're seeking primarily to identify gaps or points of pain where there may be opportunities to differentiate. This data can be gathered through ethnography, surveys, site data, or other means. The data is then analyzed with the goal of generating insights about specific opportunities that it might make sense to address through the optimization or innovation of a digital product. Those insights, or you can think of them as hypotheses, might be new features, a different user interface, a visual style, a change in content, mobile capabilities, or anything which has the potential to increase the value created by the digital product for the user and our client. Now, once we have those insights or hypotheses, we want to bring them to life so they can be effectively communicated with project teams as well as with users. So they go through a creative process, which typically yields some sort of artifact, which might be a wireframe, a screen design, or a fully functioning prototype. We take that artifact then and use it for gathering feedback, including through user testing. That testing, of course, yields new data about how the users responded to that artifact, what problems they hit, how it impacted their attitude and intention regarding the brand, product, etc. So as an example, let's say we're working with a bank and we've observed customers are frustrated with how they pay their bills. It's slow and error-prone, and it's not fun, and it's hard to keep track of who you paid. That gives us an idea for a new approach to bill payment that dramatically reduces that point of pain, at least potentially. We love our new idea, but will customers? Maybe, maybe not. If you can guess correctly 30% of the time, you've got a batting average as good as the best major league hitter and should be pretty happy with yourself. So how can we improve the batting average of what we actually launch? Well, we create an artifact. Very often, guess what? A prototype of some sort. So we can visualize that idea and iterate with our teams, as we described before, collaborative visualization. But then it is our goal to get that prototype in front of representative users, ideally in their hands, usually through one-on-one concept testing or usability testing sessions. These sessions allow us to determine the level of resonance the concept has with users, what works, what doesn't, etc. We learn many things from that data collection, which then gets fed back into our creative process, which might lead us to an insight about how to improve our original idea, or lead us to a totally different and better idea. And from that, we create an artifact and perhaps test it again. And at some point, the idea is good enough that the artifact is the actual live production application. Once that's done, do we stop collecting data? No way! At that point, the amount of data we have available increases massively. We can now observe how that application works in production, usage levels, time on site, conversion levels, etc. And we may conduct additional one-on-one tests as well with the production application to deeply understand what works and feed that back into creative ideation, and it's an ongoing, never-ending process. But back to prototypes. So the bottom line is, by iteratively testing prototypes with users, we can do a lot to refine our concept and increase the success rate of a digital product. Okay, so those are the 5 objectives that you can achieve with a prototype. Technical proof of concept, collaborative visualization, pitching, developer communication, user testing. We recommend that when you think about doing a prototype, first consider which of these you're really trying to achieve. Your core objective may only be one of these, or you may have several core objectives to start. And then if you think through this list before you begin, you may realize that your prototype could be used in even more ways than you originally envisioned and add even more value. You might need, however, to shape the scope and approach you take to your prototype based on the full set of the ways in which it's intended to be leveraged. Why? Well, for example, a prototype that is only used for pitch presentations can be kind of canned, a series of screens that follows a script. Whereas if you want it for user testing, you will want the user to click through it themselves, and it might need to have more logic built into it to simulate real interactions. A prototype that is meant for developer communications may need to show a greater number of screens so that a developer has a complete reference, whereas one used for creating training documentation may be able to get by just showing the primary flows. So knowing which of the 5 objectives for prototyping you are focused on will help guide the decisions around the other 2 dimensions of prototyping, which we touched on earlier. These are scope and fidelity. Scope is basically how much of the total experience is included in the prototype. Is it effectively all of the screens in your application, or is it a subset? Fidelity is a measure of how close to the real thing your prototype is. In general, the broader the scope and the higher the fidelity, the more expensive and time-consuming the prototyping process will be. Naturally, we want to be sure to get the maximum benefit from our prototype, but we also don't want to put more effort and money into it than is necessary. So how do you know what you need? Well, let's dive in first on the topic of the level of fidelity of a prototype. As we said, a prototype is a model of something we intend to build on a broader scale. So in theory, it could range from a napkin sketch to a functioning application in its own right. Though really, while a simple drawing could technically be considered a type of prototype, digital products are dynamic and interactive. So in my experience, the most useful prototypes allow for some type of user interaction, even if it's done in a very simple way, as we shall see. We think of 5 primary levels of fidelity, though of course within each of these levels there are gradients of realism. The first level is paper prototyping. This can utilize site wireframes or fully fleshed out page designs, or something in between. But it's basically a series of still images, slides, or printed pages that represent at least the key screens of a site or app. It's also helpful with paper prototypes that you have a way of representing the types of interactivity that exist within a page, such as additional screens for pop-ups, rollovers, accordions, and the like. Paper prototyping has a huge strength, which is that it is quick and cheap to do. This makes it very easy to do lots of iterations and improvements quickly, and to experiment with different approaches with little consequences. On the other hand, paper prototypes are fairly low fidelity. They do only a marginal job of simulating the experience a user will really have on the site or app. When we use paper prototypes in user testing, the person doing the testing tries to simulate the experience of using the site by shuffling paper around. If a user points to click on a button, the research can then swap out that piece of paper for the next screen that a user would see at that point. While fairly low tech, this can still provide valuable information about the user's interaction and understanding of the system. And as I said, it can be created and iterated very quickly. It works quite well for transactional sites, such as product ordering. However, it starts to break down on sites with a large amount of dynamic content or rich interactivity. As an extreme example, it's a very weak way of prototyping a 3D game. The next level of fidelity, the next level up, is video prototyping. This is basically creating an animation of some sort that shows how a user would use the product. It can be created using actual video tools like After Effects, or in Flash, or even in PowerPoint or Keynote. Video prototyping can make a far sexier presentation tool, and it's therefore good for pitches. It can be accompanied by music or even a voiceover story of a user utilizing the product, and that can bring to life the value proposition of the site. Of course, in a video, the flow is canned, and so this is not a good tool for user testing or really for developer communication or training either, since it's really only going to show a certain limited number of scenarios typically. The third level of prototype fidelity is a clickable image prototype. This generally involves using a tool like Acrobat, PowerPoint, or Dreamweaver to take a paper prototype and wire it together so a user can navigate from screen to screen. This type of prototype does not have working fields or controls. Each page is simply a picture, but clicking on the right area of the picture will take you to the relevant screen. For example, you might have a search box. Data cannot be entered into it. However, if the user clicks on it, they will go to a sample search results screen. The fourth level of prototype is an HTML prototype. In an HTML prototype, fields are clickable, and other bits of interactive functionality such as rollovers may work. A rotator or accordion control might function. However, the data is still canned. For example, using our search scenario described earlier, in an HTML prototype, a user could enter a search term in a search box and press a search button. However, the search results set would be canned with a single example, not reflective of what the user actually entered into the field. HTML prototypes can be created using HTML authoring tools like Dreamweaver or a specialized prototyping tool such as Axure. The fifth and highest level of prototype is an application simulation. Within this tier, however, there's a wide range of how far you might want to take it. In an application simulation, not only are on-screen controls active, but there's an underlying logic behind the prototype, which actually simulates the use of the application. For example, think of a shopping app. In an application simulation, a user might be able to browse different products, pick which ones they want to add to their shopping cart, and when they go to the checkout, the items they actually selected appear in the cart, perhaps with totals and even sales tax calculations based on the state that they live in. These types of simulations, naturally, give the most detailed experience. However, they are the most time-consuming and expensive to create. When is it worth creating such a detailed prototype? Well, for one thing, when the cost of error is high and the need to get the initial launch right the first time is critical. Furthermore, applications which are very data-intensive can benefit from this type of simulation. When doing user testing on complex financial systems, for example, it's easiest for a user to see problems with the interface if the data they are looking at is real and personal versus dummy data. Some simulations are sophisticated enough to import real production data so that a user can actually view the prototype using their current account activity and balances, for example. When looking to create very high fidelity application simulations, there are a variety of tools that can be used. Sometimes the actual tools that will be used for production development can be leveraged to create detailed prototypes of this nature. For example, a recent Drupal website we built at Moving Interactive was prototyped first in Drupal. We were then able to take the prototype and continue to build on it to create the final site. In other cases where perhaps the production technology is less friendly to rapid development, a specialized prototyping tool can be used. For simpler application simulations, Axure, which we mentioned earlier, might be suitable. For more sophisticated simulations, iRise is a widely utilized tool. And sometimes it makes sense to plan a series of prototypes that increase in fidelity as the process continues. To return to our example of Michelangelo's David, Michelangelo first created sketches, followed by small clay models, followed by a marble carving, a smaller scale than the final was, and then he graduated to the full-scale marble sculpture that we can see in Italy today. In our process, we often create and then test paper prototypes, learn what we can from those, and then move to higher fidelity forms of prototype and test that, similar to how one might use a coarse-grained sandpaper first, and then later move to a more and more fine-grained sandpaper. In the end, you have a wide range of choices when it comes to prototyping, so it's important to first be clear on which of the 5 key objectives you're going after in creating the prototype, and from there, determine the most appropriate scope and level of fidelity. Let's look at a graph that helps explain this further. So on this diagram, we're showing the 5 different objectives for prototyping and where they typically land in terms of their needs for both fidelity and scope. You can see fidelity is represented on the horizontal axis and scope is represented on the vertical axis. So let's just go through and talk about each of these. Let's start with the technical proof of concept. Technical proof of concepts, as we said earlier, very often have a user interface that looks almost nothing like the finished application will look. So a very, very low degree of fidelity to the final application. And very often they're only a couple of pages because you're testing typically some just very particular things. So they wind up in the lower left. Collaborative visualization tends to sit in the center. Why? Because first of all, you don't necessarily need the full scope of every single page of the application because typically you're collaborating around the major flows, not every error page, not every use case, not every edge case. And so you need kind of a middling amount of the scope of the application, a decent amount but not everything. And from a fidelity perspective, typically you start collaborative visualization with lower fidelity prototyping, for example, wireframes, paper prototypes, and that as the process progresses, you move to somewhat higher levels of prototyping for the purposes of collaborative visualization, but usually not to full simulations. Collaborative visualization can usually be sufficiently done with clickable HTML pages, that sort of thing. Now, when you look at user testing, see how it overlaps collaborative visualization. The scale of scope that's needed for user testing is generally even narrower than collaborative visualization. Why? Because when you do a user test session, you only have so much time. You're going to have to move that user through maybe in 20 or 30 minutes typically. The prototype, you're really only going to probably cover some of the major flows, and you're not going to cover as many aspects of the application as you might do for collaborative visualization. And from a Fidelity perspective, as we mentioned earlier, you might do your first rounds of user testing with paper prototypes or just some clickable pages, so very low fidelity, but very often over the course of the project, you want to get to higher fidelity user testing. And it often, depending on the nature of the project, it makes sense to do your final rounds of testing with some refined HTML prototypes or even application simulations. Hence, it can potentially go all the way over here to the right. Pitches typically are fairly short, showing only the sort of key screens of the application. So the scope of application is very often much smaller in the pitch than even is used for user testing. And the fidelity is fairly high. Very often you want it to look sexy, you want nicely designed screens, but of course you're generally not showing full interactivity, you're generally not simulating the application. So it's kind of in the middle right-hand quadrant in terms of the level of fidelity. Lastly, developer communication. Typically, you're going to want pretty high level of scope because you're going to want developers to have reference for most, if not all, of the pages of the application or site. And you're probably going to want a fairly high fidelity, at least visual fidelity, so developers can see and understand exactly what you want it to look like. But the cost for creating these higher fidelity, larger scope prototypes for developer communication are often outweighed by the savings from the dramatically reduced confusion and resulting level of changes and problems you have with the work that comes back from the developers. Okay, so that's all for today on this topic. There's of course more to be said, but for that you'll have to give us a call and we can talk in person. I encourage you to check out our other thought leadership videos and white papers on movinginteractive.com or find us on Twitter, Facebook, or Instagram. And if there's anything that we can do to be of help to you, please don't hesitate to call us. Contact info is on our website, or you can always email us at info@movinginteractive.com. With that, I'm Howard Tiersky, CEO of Moving Interactive, wishing you, as always, tremendous success with all your digital innovation.